This is the first lecture of Topic 7, Macroeconomic Fundamentals, and we're going through some fundamental macroeconomic concepts in this particular lecture, which will be useful later on in the course. In particular, we're going through chapters 11 and 12 from the textbook. So we're looking at gross domestic product, savings and investment, economic growth and short-term fluctuations. So what you really need to take away from this is, first of all, what is gross domestic product? What does it measure? But you don't need to go into too much detail in terms of the different ways of measuring gross domestic product. You just need to know that it is a measure of the total value of all final goods and services produced in an economy during a year, because we'll be using GDP later on in the course as a measure of output and sort of saying things such as, well, if GDP increases rapidly, it's likely to mean that employment will go up. So you only need to know GDP to the extent that it is a useful economic indicator. So you don't really need to go into too much detail in terms of how it is measured, etc., etc. So just keep that in mind when you are doing the reading for gross domestic product. You really only need to know that it is an indicator of overall economic activity, and it's a measure of the total value of all final goods and services produced. You certainly won't ever get a question asking a question specific to GDP, asking you to explain what it is and how it's derived, etc., etc. We are just using it as an economic indicator for more advanced economics in the macroeconomics section of this course. That said, you also need to understand the difference between nominal GDP and real GDP. In particular, we'll be using real GDP because nominal GDP is biased because of the inflation that's inherent in the nominal GDP measure. So make sure that you have a reasonable understanding of what real GDP is, and that it is a measure of output holding prices constant over time. Then we will look at savings and investment. Now this is very, very important. This is going to be a big theme later on in the course and right throughout what we're doing, in fact. The idea that savings minus investment is equal to the current account balance is an incredibly important component of this course. So you need to read that section very carefully and understand it in detail. In terms of economic growth, you just need to know the causes of economic growth, the key drivers of economic growth, and in terms of short-term fluctuations at this stage, once again, just the key drivers of short-term fluctuations. Later on in the course, we'll be looking at monetary policy and fiscal policy, which are a way of combating these undesirable short-term fluctuations that economies are very often faced with. But just for now, all you need to take away from this particular topic are the key causes of short-term fluctuations. So moving on to gross domestic product, keeping in mind what I said, one way of measuring gross domestic product is just adding up the four main categories of expenditure: consumption spending, investment spending, government spending, and net export spending. If we can get accurate measures of those four categories of spending, then we will be able to add them together and get a fairly accurate estimate of GDP. Now, when I say CIG and NX, they are spending on Australian goods and services. So if you buy something that's manufactured overseas, that'll actually be an imported good. It'll be classified as an import, and it won't be included in Australia's GDP. The other thing to pick up when you read about GDP is that it only includes all final goods, not intermediate goods. And once again, you won't get asked a question on that. However, it's important for you to know that GDP does include all final goods, or only includes all final goods. The other thing to emphasize on this particular slide is the distinction between real and nominal GDP. Now, once again, you won't get asked a question asking you to explain the difference. It'll just be assumed that you do know what real GDP is and why it is the most appropriate measure of output, particularly when you're looking at how output changes over time. So moving on to the next slide, I'll let you read all of this in your own time. However, I want to just convey a very simple idea that's going to be important in the coming chapters or the coming topics for this course. I want you to appreciate that there is this concept in economics called potential output. And potential output is determined by the level of capital, labour and technology available to an economy. The way I like to think about potential output is that it is the level of real GDP that a country can produce at a comfortable level indefinitely. So let's ignore economic growth. Economic growth is just an unnecessary complication in explaining this concept, so we'll ignore it. Let's just imagine that there is no economic growth over time. Potential output is that output level which is sustainable year after year after year after year. So let's assume, as I've got at the top there, that it is $1.5 trillion in Australia. Now, to help you grasp this concept of potential output, let's think about what would happen if an economy goes beyond potential output or below potential output. And before I talk about this, just take note that potential output is just a theoretical level of output. It's very difficult to actually measure what this level of output is, but it is a concept in economics that is very important because it's linked to the business cycle and it's linked to excessive inflation and excessive unemployment. So let's just imagine that potential output, we could somehow measure what it is, and it's $1.5 trillion worth of real GDP in Australia. If the economy goes beyond this level of potential output to say 1.7 trillion, then we are going to get unacceptably high inflationary pressure and eventually inflation. If we go below potential output, then the level of unemployment will become too high. Soon in the course you will read about how there is always some unemployment in an economy, so unemployment can never fall to zero because people are always leaving jobs, taking 3 or 4 months leave and enjoying themselves before they find another job and go back to work. So that sort of person is unemployed during that transition period. That's just natural. It's natural unemployment. Some type of unemployments will always exist. So when I say if an economy falls below potential output, unemployment will increase, I'm sort of saying unemployment will increase beyond that sort of natural level. So at potential output, that's another way of thinking about it. Unemployment is at a natural level at potential output. So if we go beyond potential output, inflationary pressure begins to build and we can't sustain being at that very high level of potential output for very long because it will eventually lead to unacceptable inflation. And if we're below potential output for too long, we're in a situation where unemployment is unacceptably high. And so the whole idea is that an economy likes to be or should be at potential output or as close to potential output as possible to avoid the problems of high inflation or high unemployment, depending upon which side of potential output you are actually at. So that's why potential output is important, because if we know roughly what it is, then fiscal and monetary policy, i.e. government policy, can actually manipulate the level of spending in the economy to try to get the economy close to potential output. Now, when we add the complication of economic growth, all that means is that the level of potential output is growing from year to year, along with growth in the capital stock, the labour force and technology. So really this potential output over time in dynamic setting is really just a moving target that policymakers need to try to hit in terms of keeping actual real GDP as close to potential GDP as possible over the business cycle. Okay, so that's GDP, and that's really what you need to take away in terms of your knowledge of GDP. Key thing there, it is an economic indicator of economic activity, so it will be useful in terms of talking about economic growth and business cycle fluctuations, to be able to talk sensibly about real GDP and what it is and what it isn't as well, of course. Having in the back of your mind what real GDP doesn't measure, and that's mentioned in your readings, is useful. Not essential, but useful. Now we come to domestic savings and investment. So we have seen this set up before. We've got demand and supply analysis, where investment creates a demand for loanable funds and savings creates a supply of loanable funds. And in this example, I've got a closed economy. So Australia does not trade with the rest of the world, particularly in terms of money. investment money, savings, that sort of thing. So on the vertical axis, I've got the real interest rate, that is the inflation adjusted interest rate. And if the economy was closed and the market for loanable funds was competitive, then the equilibrium interest rate would settle at 6%. Savings would equal investment, and therefore savings, which are a leakage out of the economy, would equal investment, which is an injection back in. So leakages would equal injections, and the loanable funds market would be in equilibrium. So if the economy is closed, the domestic money market that I've drawn here would be in equilibrium, where savings equals investment. Now, I'm not making the distinction between short-term money markets and long-term money markets and short and long-term debt here. This is just a very general principle that I'm trying to get across, and it really applies in aggregate across all debt markets. If you want to start thinking about different debt markets, then this is a way, the easiest way to sort of rationalize this slide is to aggregate all of those debt markets up and say that at any point in time, across all of the debt markets, national savings and national investment must equal each other, i.e. the supply and demand of loanable funds must equal each other. Now, this is a closed economy, and it's really not an accurate representation of the situation in countries like Australia. So if we go to the next slide, this is more representative of an open economy such as Australia and our situation in terms of domestic savings and investment. Now, we've got, once again, the demand and supply of loanable funds, which I've just called national investment and national savings respectively. But now we don't have a domestic interest rate of 6% because interest rates in Australia are to a large extent driven by global interest rates. Now, one thing that I should mention here is that you will have spent quite a bit of time learning about the differences between short and long-term debt markets. That is, short-term debt, more sort of discount securities, long-term debt bonds. Now, when we are, the other thing that you would have picked up by now is that interest rates on short-term debt are driven mainly by the cash rate, and interest rates on bonds or long-term debt are driven more by global forces. That is, interest rates in the key financial centres of the world through capital mobility, international capital mobility. Now, another thing that you need to appreciate is that long-term debt markets relative to short-term debt markets are much, much larger. So there are many, in terms of the size of these long-term debt markets, they're huge compared to short-term debt markets. So when we're considering savings and investment imbalances in a particular country like we're doing here, see in this diagram I've got a level of savings equal to B, sorry, a level of savings equal to A and a level of national investment equal to B. That savings investment imbalance, when we're considering a thing such as national savings, national investment and imbalances, I'm really talking about long-term debt markets here. So what's happening, and to explain that, what's happening in this diagram, we have an imbalance between savings and investment at the global interest rate of 4%. So just imagine that 4% is the 10-year bond interest rate. At that interest rate, we've got local borrowing requirements equal to B, and we've got local savings equal to A. Now, once again, this is a general principle, and I'm trying to sort of fit this explanation into the sort of the money market analysis that we've done previously, which makes it a little bit complex to do that when you're trying to fit a general principle into something quite specific. But we'll continue along with this. So we've got this 4% global interest rate, which is the interest rate in sort of the US and Germany and other key financial centres. And that is saying that because 10-year interest rates are roughly 4% in the key global financial centres, they're going to be close to 4% in Australia under normal economic conditions. So if 10-year interest rates in Australia at 4%, we're going to have savings at A, so that will be the amount, A will be the amount of domestic savings going into 10-year bond markets, and we will have domestic borrowing at B. Now we've got a gap there between A and B, which is a shortfall of national savings over national investment. Now if that's the case, the only way we can fund all of our borrowing requirements in this country is to bring in foreign savings equal to the horizontal distance A to B. So A to B is equal to the net inflow of foreign savings. And that is really just a consequence of this open economy and open financial markets that we have in Australia. We don't have a domestic interest rate of 6%, which creates equilibrium between domestic savings and investment. We have a global 4% interest rate, and that then means savings can be less than investment, and we allow the difference to flow into the country. So what I was getting at before was that if money does flow into Australia equal to AB, it will flow, a lot of it or most of it will flow in through the bond market. Some of it will flow in through the stock market, that is true. But to keep things nice and simple at this stage, we will just assume that most of that money, AB, flows in through the bond market. Okay, and then this next slide. What I've got in the top left-hand corner is just the same diagram that I had previously. I've just rescaled it. So we've got this amount of money, AB, flowing in to the Australian economy at the 10-year interest rate in Australia of 4%. Over here, B minus A is now the net inflow of foreign savings into Australia through either the stock market or the bond market, but most probably the bond market. And so what I've got down here is that the amount of money B minus A, so that's just the horizontal distance between B minus A is the horizontal distance between A and B. That amount of money is the foreign savings coming into Australia, and as that money comes into Australia, it will be recorded in the financial account section of the capital financial account. So in Australia in 2010-2011, we can see the financial account balance is $40.493 billion. So in 2010-2011, that gap between A and B was $40.493 billion. That was the gap between national savings and investment. Now at the same time, the other thing that you need to appreciate, and you'll really develop a full appreciation for this in the final topic of the course, is that this gap, AB, also equals the current account balance. Now it's not exact because of the capital account. The capital account does have some small entries in there, and there is a small capital account balance. But broadly speaking, very generally, the savings investment gap, which is A to B, is going to equal the financial account balance. And the financial account balance is by far the major part of the capital financial account. And that capital financial account balance will equal the current account balance there. So in the book it talks about savings minus investment equaling the current account balance, where you can sort of see the way it works. A minus B is approximately $41 billion, 40 to 41 billion, and S minus I is negative, and that is equal to the current account balance up here, roughly $41 billion. I know the numbers are not exact. That's simply because this is a very simple model that we're developing here. It doesn't include everything that actually happens in the economy. So the numbers aren't exact, but we're getting pretty close in terms of the numbers actually matching up. So A minus B, or A to B, is 40 odd billion, and that's roughly equal to the current account balance.